So good afternoon again to everyone, and welcome to the 11th of the 13 webinars that are part of the 2020 EMOS Webinars program. My name is Caterina Giusti. I'm Professor of Statistics at the University of Pisa in Italy, and today I will act as the webinar facilitator. As this is a live event, I would like to specify that today I'm connecting from my house, as all the other members of the EMOS staff of the University of Pisa as our speaker, and I guess as many of you. As for the past webinar, I'm happy that we have this opportunity to join all together for the EMOS webinars, which are indeed a powerful tool that we can use also in these difficult times. So now going back to our webinar, let me first explain for any newcomers that EMOS stands for the European Master in Official Statistics, a joint project of universities and data producers in the EU member states, FTA and EU candidate countries. If your university is interested in applying for the EMOS label, please consider that a permanently open call for universities is available on the EMOS dedicated page on the Eurostat website. For staying in contact with the EMOS news and community, please follow the EMOS on Twitter. The EMOS account is @EU_EMOS. Now, before I give the floor to our speaker, let me first briefly explain how we run the webinar today. As a participant, you can watch and listen to the session. To interact with the presenter, you can use the chat, represented by the comic symbol. We encourage you to prepare your questions and post them during the presentation or during the question break or the final discussion. Should you have any technical problem, please try restarting the Skype for Business or a computer or device that you are using. For more specific technical questions, you can use the chat. In any case, please consider that the slides of the presentation are already available on the EMOS 2020 event website, and we indicated the link on the chat for the slides. So today, I have the great pleasure to host Claudia De Vitiis from ISTAT, the Italian National Statistical Institute, and her co-author, Francesca Inglese. She's also from ISTAT. She also is together with us at this webinar. So Claudia De Vitiis is senior researcher at the ISTAT. She is responsible for the unit Design of Sample Strategies for Complex Surveys and Mixed Mode Social Surveys. Currently in charge for studying and defining sample designs and strategies for social surveys on households and individuals. In particular, a research topic studies in depth during the last years concern mainly the assessment and treatment on the mode effect in mixed mode survey designs, the use of scanner data for the production of consumer price indices, and methodologies for smart surveys. Recently, she is involved in the European project ESSnet Smart Surveys, for which she coordinates the work package in charge for the development of a methodological framework for the definition of an European platform for trusted smart surveys. Francesca Inglese is a methodological researcher at the ISTAT. She is responsible for the unit sampling techniques for hard-to-reach populations. In recent years, her main research topics concern sampling strategies for social surveys, sampling techniques for homeless population and the LGBT population, the treatment of total no-response, the assessment and treatment of the mode effect in mixed mode survey design, the use of scanner data for the production of consumer price indices, and the definition of smart surveys methodology within the European ESSnet Smart Surveys project. So today, Claudia De Vitiis will present about the mode effect in mixed mode surveys. As I was saying, her co-author Francesca is also connected to the webinar, and so she will be able to join the final discussion. So Claudia, the floor now is yours until the first question break.
Okay, thank you very much, Caterina. Can you hear me well, I hope?
Yes.
Okay, so good afternoon to everybody. I am very honored to be here and giving this webinar. And this seminar follows the very interesting seminar held by Professor Giliu 2 weeks ago on mixed mode surveys, and I guess that most of you have followed also that seminar. This seminar has the goal to present a review of methods to assess mode effect. In fact, We will focus on the impact that mixing of techniques has on the estimates deriving from mixed mode survey. The impact in terms, especially in terms of bias or risk of bias. So, excuse me. The presentation is in two parts, is divided in two parts. In the first one, a more theoretical one, definition, and methods to assess and adjustment mode effect will be presented. And finally, in the part B, a case study will be presented on an experimental design with the parallel independent surveys, in which we have tested several methods that I will present in the part A. Sorry, I need, okay. What is the mode effect? First of all, a definition of mixed mode survey design. So the mixed mode is the use of different data collection techniques in the same survey. Is a use that has spread in recent years. Recently, many surveys are based on a mix of techniques. The techniques can be paper and pencil, postal, paper and pencil interview, CAP interview, computer-assisted person interview, the CATI with the telephone, the CAWI, computer-assisted web interview, which recently has become also smartphone-assisted web interview, but in our discussion, we consider the web interview as a whole. So the choice of the technique must be made according to the objective of the survey, of course, and the characteristic of the population in order to maximize the quality and limit the burden, keeping in mind also the cost of the survey. So mixed mode has several advantages, of course. In fact, it allows to contrast the declining response rate and the coverage rate of the population, because the sampling unit can be contacted in the most suitable way for each of them, keeping into account, for example, the way of contact, telephone, web, or direct interview. Moreover, mixed mode allows to reduce the cost of the survey, for example, using cheaper techniques such as the web mode. So, simplifying, we have two main types of mixed mode designs, the concurrent and the sequential. In the concurrent design, the modes, the chosen modes are assigned to the units ex ante. So we have different separate samples chosen by the researcher, and the choice can be done or randomly or on the basis, this is perhaps the more frequent case, on the basis of known characteristics about the sample, the unit of the population. So generally two or more than two different samples are defined. In the sequential mixed mode design, on the contrary, we have a unique sample and the same mode. The first mode is proposed to all the sampling units, and then the non-respondents are reapproached using a different mode. Usually the cheaper one is used first and then the most costly. So mixed mode has several advantages in terms of data collection, population coverage, response rates, but it presents complexities. Complexities in particular because the estimate that the survey has to produce must be consistent and comparable with the analog ones obtained in previous survey edition. So we must be sure that any changes in the time series of estimates are due to real changes of the phenomenon and not to measurement error or other effects, other bias effects. So in the design phase, actions should be taken to reduce the risk of introducing non-sampling errors in the survey through the planning of a suitable data collection instrument in order to reduce the risk of measurement error. And the choice are unimode or mode-specific questionnaire, but this is not the focus of my presentation. The focus of my presentation is especially in the estimation phase, when analysis and possibly adjustment of the errors introduced by the different techniques can be conducted to ensure the accuracy of the estimates. So let's give some definition about what effect. So more refers to the introduction of bias effect on the survey estimates due to both observational and non-observational error. We have two kinds of effect, a selection effect and a measurement effect. The first one consists in different coverage errors and total no response of each technique. And here we have non-observational errors that can determine a difference in the composition of the observed samples. We can underline that selection effect is a desirable aspect of the mixed mode strategy, because we mix modes because we want a selection effect. We want to cover different type of population and with different modes. But we have to take into account that this selection can have some problem, some bias in the estimates. Then we have the measurement effect, which is different, for which we have different measurement errors to the different modes, and that can introduce systematic differences in the data. Measurement error refers to the influence of the survey mode on the answer of the respondent, such that one person can give different answers to the different modes. Examples are the interviewer effect, so the presence of interviewer can affect the answer of the people, social desirability, and other effects. So the assessment of the mode effect is very complex because the two effects are always confused. This is the main problem in this context. And the consequence of this problem is that a discrepancy in the estimate calculated on the respondent can be caused by the different composition of the sample or by the difference in measurement error, but it is very difficult to assess and to understand. So the main problem is to disentangle the two effects for the estimation of the measurement error, which is what we want to estimate. But before, we have to disentangle and to estimate also the selection effect. So here for 3 or 4 slides, we have a bit of formalization, on which I will go quickly, but I think it's very important to understand what these effects are. So selection and measurement effects are contained in the relationship between the survey variable and the mode, but they act in a dissimilar way. The measurement effect produces differences in the estimate means on the respondents, while the selection effect influences the correlation structure of the data and produces measures not equivalent among the respondents. Here we put many references, and sometimes I will read them, sometimes not, but they are all listed at the end of the presentation. So the reference concept for mode effect analysis is the equivalence of the mode measurement. This concept can be illustrated introducing a simple measurement model derived from Claudia 2014, in which we have the expected value of a y variable collected by mode M1 can be written as the expected value of the variable, true value, plus a systematic measurement error due to mode 1. The equivalence of measurement with two modes is achieved when the measurement errors associated with the two modes are the same. So we have the same systematic measurement error for mode 1 and mode 2. In this case, we don't have measurement effect. Sorry, I have some problem with, okay. So for the estimate of an average of this generic variable y, we can start from the decomposition of the total bias, and we can define the estimate of the total mode effect and its component in order to understand what these components are. So we can start defining the average obtained as a combination of data collection with the two modes, using the proportion of responder to each mode and the two sample mean. We can define the expected value of the sample mean estimator for the respondent with mode 1 by using the conditional on the response to mode 1. So we have that the expected value of the sample mean of y with mode 1, we can write as the expected value of the y with mode 1 conditional on the response with mode 1. And the same, of course, with mode 2. So the total bias of the estimator with mode 1 can be expressed with a simple algebra. We can be expressed as the sum of a measurement error, conditional on response, and a selection error with respect to the population mean. So the total bias of the estimator of the mean of the average with one mode can be expressed by the sum of this factor. Mode on the total by error depends on how the specific errors associated with each mode operate in combination. Now I can give a simple example of the estimator of the total mode effect in the situation when we have a concurrent mixed mode design, which is simpler because we have independent sample. We don't have one sample conditional on the other, such as in the sequential design. So for the concurrent design, we can define the estimator of the total mode effect due to the mode M1 and M2 as the difference between the two sample mean. The expected value of this estimator can be written introducing the conditional on the response to mode 1 and mode 2, can be written in a very interesting way as the sum of two components, the measurement effect and the selection effect. The measurement effect is the difference between the measurement errors due to each mode, and the selection effect is the difference between the two selection errors. The problem is that all these quantities usually are not observable and are not evaluable in a direct way, because we need to know the true value of the population or what we would have observed with the other technique. So with the technique not chosen by the respondent. Now we will see what I mean. In fact, we can use a trick which is perhaps the basis of most of the inference conducted in this context. In fact, we can consider that the true value of the measurement can be obtained with one of the two modes that we call a reference mode. For example, the mode 1. In this case, we can obtain that the measurement effect is the measurement error of the mode 2, because mode 1 hasn't measurement error, and the selection effect is the selection error with respect to the variable measured with the mode 1, having introduced a special quantity, which is the counterfactual quantity, also called potential result, which is the expected value of the y observed with the mode 1, but on respondent to mode 2. And this is, of course, a quantity that we haven't observed, but that under certain condition we can estimate. Okay, so having highlighted some algebra regarding the mode effect, we can focus now on a review of methods, on a review of a situation in which some methods can be applied under certain conditions. So, first of all, we can have two types of design type, an experimental design and a non-experimental design. When we have an experimental design, we can, of course, carry out more deep analysis, and we can apply more methods, a higher number of methods, to have both mode assessment and eventually and possibly mode adjustment. The experimental design can be parallel independent surveys, for example, one single mode and one mixed mode, or we can have the re-interview study with the repeated measurement of the same variable with different mode on the same respondent, or other experimental designs such as embedded experiment, split sample design, and so on. For non-experimental design, we have only the mixed mode design that we are observing, so we are in an observational study situation. In the first case, we can perform mode assessment and mode adjustment. In the second case, we can control for selection effect through weighting or regression-based inference. And sometimes we can adjust for measurement effect. In this table, we have selected some of the methods that we found being very interesting, because the literature on this topic is very, very wide and the methods are complex. Because there is always the need to disentangle the selection and measurement effect in order to come to an estimate of the measurement effect, the measurement error. So we have selected some of the methods that we can find in the literature. These methods have been classified according to the type of analysis, the conditions, and the context on which they can be applied. Some methods can be classified as weighting methods, which can be used in the observational studies under the assumption of missing at random, with the need of a mode insensitive auxiliary variable, and analysis based on response model to control for non-respondent characteristic can be performed. Then we have regression models with which we can analyze estimate measurement and selection error. Also in this case, a mode insensitive auxiliary variable are needed. Then we have other methods. I'm not reading the reference, but you can find all of them at the end of the presentation. Then we can have other methods, for example, the use of outcome regression with propensity score model. We have methods based on the use of instrumental variable, which can be used when two parallel independent surveys are available. And we have the re-interview method, which allow to estimate the measurement effect and the selection effect. Okay, just a few words about the theoretical framework in observational studies. Observational studies are when we don't have an experimental setting. So from an experiential point of view, the selection and measurement effect is to be investigated separately to obtain a correct formulation of the total non-sampling error and to apply a method to adjust possibly the estimate of the parameter of interest. The problem of the confounding between the two effects is the central theme of the theory of causal inference formalized by Pearl. In this context, the measurement error is conceptualized as a causal effect of the mode on the survey variable, while the selection effect is seen as a spurious correlation between the target variable and the mode. So we need to isolate the selection effect in order to estimate the measurement effect. For the estimation of the two effects, the causal inference is used according to a counterfactual perspective. So the existence of a potential result not really observed is assumed. For observational studies, there are requirements. In particular, we need covariates that explain the selection mechanism. If these covariates are available, the differences between the mode groups can be attributed to measurement difference conditional on the covariates. The types of auxiliary variable for the causal inference can be classified in confounding variable and intermediate variable. We have here the reference to a very interesting paper. Just a view, a very synthetic view on a method to adjust mode effect. Adjust mode effect is very difficult. We can adjust for the selection effect or also in some cases for the measurement effect. So we have also in this case classified some of the methods that we can find in the literature. We have classified them in some types, the weighting, which can be propensity score, calibration, or post-stratification, with the scope to equate the sample and correct selection effect under the condition of ignorability of the selection mechanism, the existence of modic sensitive auxiliary variable, and also under the hypothesis that the measurement error is negligible. Then we have a very interesting method with this mode calibration proposed by Bull and Savant-de-Brakel, which has the aim to stabilize the selection effect in repeated mixed mode survey. Then we have a method based on regression, which have the aim of estimate the measurement and selection effect, and in some cases to correct the measurement error. Another class of methods are the multiple imputation methods, which can be the multiple standard imputation or the imputation with response and selection models, or the fractional multiple imputation proposed by Park in 2016. All these methods have the goal to predict the counterfactual data, so the potential outcome with the other mode, and to correct measurement error, of course, subjected to a lot of conditions. Just a few words to conclude this first part, just a few words about the method for adjusting the selection effect through the weighting. In this case, we have the propensity score, on which I will give you a short focus later on, the standard calibration demographic total, and the calibration of fixed level of mode proportion, which I was mentioned before, to stabilize the selection effect, assuming the invariance of measurement error, with the aim to obtain reliable changes over time. So I think that at this point we can have a small break, a short break.
Okay, thank you, Claudia. So participants, if you have any questions so far, you can use the chat. Otherwise, of course, we can go on, but please, if you have questions, this is the moment. Otherwise, of course, you can also pose them at the end of the presentation when we will have the final discussion. So no questions seen for the moment. Let's wait another second. Of course, the first part was very specific, so maybe we will have more questions at the end. So I think, no, I think we can go on. Claudia?
Okay, thank you, Caterina. So yes, I can move to the last part of my presentation, and a last part on the method. Then we have experimented in several situations, which is the use of the propensity score for in the case of the observational studies or a mixed mode survey, and which can be used for disentangling selection and measurement effect and obtain an estimation and assessment of both effects. It is a weighting method based on the theory of Rubin and in general, and on the paper by Van Plas in 2016, which proposed the use of a propensity score for the mode effect assessment. The aim is to make comparable the respondents to the different modes under the assumption that the differences between the comparable groups are due only to measurement error. So we want to separate the samples into groups according to auxiliary variables, so that in these groups we can evaluate the measurement error. So the method is based on the idea of equating the distribution of the samples of respondents with different modes conditionally to a set of auxiliary variables, which are supposed to explain the selection effect. So they are confounding variables. These auxiliary variables should be, of course, mode insensitive. So if collected through the survey, we have to be sure that these variables are mode insensitive, or even better, we can have these variables from registers or archives. The hypothesis of this method is the ignorability of the selection effect and the invariance of the measurement error determined by the mix of modes over time. So what are the main features of this method used in mixed mode survey? So the method is part of the causal inference in a counterfactual perspective as an application of the backdoor model. The propensity score subclassification is used to disentangle selection and measurement effect. The propensity score, in particular, can be interpreted as the probability of assigning or choosing the mode conditionally on the observed cover rates. This propensity to respond to one of the modes is modeled using a logistic models, and the propensity score is obtained as the predicted probability of this logistic model. These predicted probabilities are used to create groups of comparable respondents to mode. To mode 1, which we choose generally as a reference mode, and mode 2, by different methods, matching or stratification. Usually we have used stratification using the percentiles of the distribution of the predicted probabilities. So the comparability is performed. So the answer provided with the mode M2 must be made equivalent to those that would have been provided by the mode M1. So the goal is to find counterfactual data. So M1 is considered as a reference mode. Within the groups, the balancing condition has to be verified. So in each stratum, the independence between each auxiliary variable and the mode must be verified with an appropriate statistical test, because we have to be sure that in the groups there is independence between the auxiliary variable and the mode. In each balanced stratum, a weight is calculated, which makes the weighted proportion of respondent to mode 1 equivalent to the proportion of respondent to mode 2. Using these weights, this weight, which is based on the count of mode 1 and mode 2 in the different strata that we have defined. Having defined the groups and weighted the respondent within the groups, it's possible to estimate the components of the mode effect, so the selection and the measurement effect, following, I already said, Van den Plas et al. 2016. In this paper, the selection effect and the measurement effect, as following this paper, this effect can be estimated in a very simple way. The selection effect through the difference between weighted and unweighted estimate on respondents on mode 1, and the measurement effect as the difference between the weighted estimate on respondent to mode 1 and the unweighted estimate of the respondent to mode 2. And we will see an example of this, for the application of this method later on. So I've finished the first part of the presentation, the theoretical one, let's say, and the last minute of my seminar will be devoted to present a case study, so an experimental design with parallel independent samples in which we have conducted the assessment of the mode effect. So the objective of our experimental design is to evaluate the impact of the introduction of the mixed mode in an ISTAT social sample survey. So the name of the survey is Aspect of Daily Life, which is an annual survey, which was traditionally a paper and pencil interview survey. In 2017, ISTAT switched to mixed mode design, but setting a experimental situation. So 2 parallel independent samples have been selected, have been observed. The first sample was interviewed by single mode, so the traditional puppy interview, and the second sample was collected by the new design, mixed mode, a sequential web puppy. So I'm going to present analysis and models and some results. So a few words about the sample, which is the multipurpose survey on households, Aspect of Daily Life. This survey collects a lot of information about the several aspects of daily life, cultural activities, free time, sports, and so on, the use of internet, the relation among peoples. It is based on a sample of about 24,000 households, selected through a two-stage design. The technique currently is a mixed technique, sequential web puppy. So to the entire sample, a self-compiled questionnaire is proposed in the inviting letter, and after a non-respondent, direct interview is with the questionnaire of paper and pencil is administered. The selected sample in the experimental setting of 2017, the selected sample was linked to administrative database in order to get relevant auxiliary information from another source. So here we have a synthesis, a scheme of the analysis that we have conducted on this experimental setting. So we have followed different phases of our analysis. The main goal of the analysis was the evaluation of the impact of the switching from single to mixed mode in order to evaluate the total non-sampling error components and to understand if the difference in the time series of this survey, of the estimate provided by this survey were due to changes in the phenomena or in changes in the interview technique. So the theoretical context in which we are is counted factor approaches. We have auxiliary variable available from registers. And the phase of the analysis are the comparison between the estimate obtained with the two surveys, the single mode and the mixed mode, through test on the difference, the study of the total no-response bias. Then we have analyzed the univariate distribution and multivariate structure of the data, which is a very interesting study. And then we have conducted the assessment of the mode effect, disentangling, trying to disentangle selection and measurement effect through propensity score and instrumental variable. Then we have tried to conduct also some adjustment through weighting, but we haven't obtained very nice results on this aspect. So just a few numbers on response rate. In this table, we can see that the general response rate is 71%, and there are differences among the geographic areas. In particular, for the single mode, we see that the single mode obtained at 71%, and the mixed mode design obtained at the end 74%. And the percentage of the web was 26.8%. So it is not a higher percentage in Italy. And this percentage is also very different from region to region, from north to south. So this is also an issue to be considered when assessing mode effect, because also the regional component, the regional variability is very important. So here we have the list of the auxiliary variables that we have derived from registers, are characteristics of the household in terms of typology, higher educational level, occupation type, municipal type, geographical area, income class derived from register, and citizenship. These are the variables that we used in the models. So the first type of analysis, which was very interesting, was the use of R indicators, which are based on the measure of the variability of the response propensity, and describe how the sample of respondent reflects the population of interest with respect to the auxiliary variables. It is based on the variability of the predicted probability through a logistic regression model. In this table, we can see a synthesis of the results we obtained using the R indicator, and we can see that the mixed sample, the MM sample, obtains a higher value of the R indicator, indicating that mixing the technique produces a more representative sample, and this is a good news for our survey. In particular, the difference is very high in the south of Italy, despite we had a lower percentage of web respondents. So we can see that the factors are mixed up. Okay, let's change. Here we have another interesting analysis that we conduct in this experimental context. In fact, the user's interest is generally in the relation among variables, which are studied through statistical model. So the very relevant question is, what is the impact of data collection design on distribution and or associative structure of the variables? And so following the paper by Martin and Lin, 2011, we have performed univariate and multivariate analysis in order to understand if there is an impact of the survey design. Here we have two designs, the single mode design and the mixed mode design, to understand if the design of the survey has impact on the univariate and multivariate structure of the data. In fact, significant interaction effects would show different relation among structural and target variables depending on the survey design. So a researcher using the data of this survey has to take into account that the design of the survey has an impact on the structure of the data gained. In fact, what we have found is that for some of the target variable of the survey, for example, the frequency of seeing friends, performing physical activity, playing sports, we have found that a significance of the models relating the sample design and the target variable. In particular, in the model with the interaction, we have estimated that there are a significant effects of the survey design between the survey design and the auxiliary variable in influencing the target variable. Here we have the auxiliary variable resulted as a significant in a single effect on the target variable, and in the following table we have the variables resulted to be significant in the interaction effect. So there is a significant interaction effect between the survey design and the auxiliary variable in influencing the target variable. And this is, in our opinion, a very relevant warning for the researchers which will use the data of this survey in order to perform data analysis. The last result I'm going to present is the result obtained using the propensity score in order to disentangle the two effects, measurement and selection effect. I have already illustrated the use of the propensity score in this context. I can add that, yes, we have defined the propensity score model at household level, because the choice of the survey mode depends on the household, because it is a survey on household. So we have a binomial logistic model at household level, in which the survey mode is modeled, is a function of all the auxiliary variables we have considered. We have calculated the weights for each group defined under the decile of the propensity score distribution, and we have verified the balancing condition of the groups. And finally, we have evaluated the effect, selection effect, and the measurement effect for some. Here we have a choice of target variables. We have highlighted that for some of these target variables, for example, reading books in the last 12 months, no or yes, there is a suspect, let's say so, of measurement effect, a minus 13% of measurement effect on this category, for example. So indicating that for this survey, we have found that the mixed mode allows to obtain more representative sample, but there is a suspect of measurement error, which should be dealt by the researcher who is in charge of the planning of future edition of the survey. So some final consideration. We are concluding the presentation. Final consideration, especially on the experimental design. In fact, for this survey, we have verified that the introduction of mixed mode has an important impact both on the composition of the sample, improving the representativeness, but also on several indicators whose quality seems to be affected by measurement errors. Moreover, the mixed mode seems to have an impact also on simple and complex analysis, and the application of the presented method, of course, we have to underline, is subjected to the validity of the hypotheses underlying the methods themselves. Moreover, the set of the analysis that we have presented, of which here in this presentation we make a choice of the analysis because we have exploited this experimental setting for conducting more and more analysis, but the set of the analysis can be applied in a similar context and can be considered a possible checklist, a sequence of steps usable by researchers, by other institutions or university. Generally, what we can conclude by all this work is that the effort underlying all this analysis is generally non-compatible with the user resource and the timing of a statistical process. So in general situation, is very important then an accurate planning of the data collection. We would limit ex ante the measurement effect, because the measurement effect is the main drawback of the mixed mode. And apart from assessing and estimating and possibly correcting it, it's very important to be avoided before the survey. Okay. Here you have a selection of references, and I thank you for your attention.
Thank you, Claudia. Thank you very much for this very interesting presentation. So, of course, again, I ask to our participants if they have questions, they can use the chat. I'm just curious, while we wait for questions, in the meanwhile, if you can give us an idea of course, thinking about ISTAT, the Italian National Statistical Institute. So, concerning surveys on households, on the population, let's say, households, how many are mixed mode now? Because I think that the number is increasing or not. I don't know, so I'm asking.
Yes, thank you for the question. Yes, ISTAT is conducting many mixed mode surveys. I think that the first that have become mixed have used the CATI and CAPI technique. So computer assisted with interviewer. And in this case, the effect of the mixing of the technique is not so strong, because the strong effect is when we we switch to the web.
Mm-hmm. Okay.
So, but also there are more than one, I think 2 or 3 surveys which have switched to a mixing of web and direct interview. And for all these surveys, yes, this is one. Then we had the first one in 2015, a survey on sports and culture habits. And but yes, the majority are mixing of CATI and CAPI. So in that case, the effect is more slight.
Should lower. Yeah, okay. So in the meanwhile, we receive a couple of questions. So the first one says, Claudia, are you aware of the effects of mixed mode surveys in labor force surveys during the COVID pandemic? Very specific.
Okay. Yes, we have also changed the data collection technique during this period. So we had, yes, we were in the. It was impossible to conduct direct interviews, so we moved in a few weeks to a CAT interview, selecting a new sample. So, but yes, we are aware of the effect, but of course we hadn't the time to assess it. I think that in the next month it will be challenging to understand what is happened by changing the technique on the run, let's say so. And so, yes, we are aware.
Yeah, very challenge. Yeah, we have another question. So you say, thanks for the presentation. You mentioned that some adjustment was used without good results. Could you give some more details? So maybe they're also curious to know what was not working. Yeah.
Yes, I didn't show the table with the adjustment because we had tried several calibration methods in order to correct the selection effect, but it was perhaps a surprise that the estimate was not so different. So using the mode calibration proposed by Boolens, or using the weights obtained by the propensity score, or standard calibration, the results were not so different. So in this presentation, we decided not to show them. But yes, we have published this result in some paper that perhaps we can add to the references.
Reference list. Okay,
yes.
Thank you. So no more questions. I have another curiosity because I'm not an expert. So about because of course you have this very low response rate for the web part, especially in the south. But how is the web part conducted? I mean, you first contact the household and you ask an address. So how is the contact to the web?
No, the contact is with the paper letter. Is inviting letter sent by ISTAT, in which the household is invited to
participate,
provide the interview by web, in the web questionnaire. So the credentials are provided in order to connect
login,
to the
login,
password, and so on. And then usually some recall is sent to the household, not respondent, I don't know, in 1 month or 2 months. And afterwards, the interviewer goes to the address and proposes the direct interview, the face-to-face interview, with the previously with PAPI, now with CAPI, computer assistant.
Okay, so the first contact is the same, the sampling technique that is doing the same. The first contact. Yeah, okay.
It's better sent by ISTAT to the households. Yes.
Okay, thank you. So if we have no more questions, I think we can conclude. So I thank you, Claudia, again for this very interesting presentation. And I also thank our participants who joined us today from many different places. So as we already said, you can already download the presentation from the EMOS 2020 events website, where the link to the recording of the webinar will be also available as soon as possible. And the recording of the past webinars are also available on the YouTube channel European Master on Official Statistics, EMOS. In the meantime, I kindly ask you to check the inbox of the email account you used for registering to the webinar, as you have already received the link to a short survey about today's webinar. We'd really appreciate your feedback to further improve our webinars. The next webinar is scheduled on Tuesday, the 9th of June, when Timothy Allen from the Eurostat will be presenting on recent developments in publishing statistics. I hope that you will join us also on this and on the last webinar of the 2020 EMOS webinar program. So thank you very much, Claudia, again to the participant, and have a nice evening. Bye-bye.
Bye-bye. Thank you very much.